I can break down, just means to decompose, polygons into smaller figures to find the area. Okay, very easy to do here. First of all, I want to show you the definition of regular because maybe you don't remember. What a regular polygon is when all the sides are the same. Okay, now a polygon itself is just any closed-in figure with 3 or more sides. So that's why polygons are, triangles are a type of polygon, parallelograms are a type, quadrilaterals are a type, decagons, hectagons, or octagons, all those. Okay, there's a ton of them. Pentagon. Okay, this right here is a regular pentagon. You can see it's got 5 sides, which is what a pentagon is, and it's regular, which means that all 5 of those sides are the exact same length. Okay, and it gives you this, and we're going to basically be able to find the area of this pentagon, not by a formula. We're not going to learn some crazy formula. If you get a chance, go onto Google and just Google area formula for a pentagon. I'm sure there's an equation or a formula out there. I just have no idea what it is, and quite frankly, I don't care because I know that I can decompose this into other shapes, and that's exactly what we did here. They put a dot here. That dot's called the center. Okay, please write that. If my pen would work. It's not been a good day for the pen. Okay, this is my center. Just means it's right in the very center from all those angles. And basically, what we've done is we have created we've created 5 triangles. You can see that, guys. You just took it from the center and you connect it to one vertex. Okay, vertexes are just where the 2 sides meet each other. There's a vertex. There's a vertex, 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 and then a vertex. And you can see we've created 1 triangle, 2 triangles, 3 triangles, 4 triangles, and 5 triangles. Again, here, guys, I want to make sure you're understanding this. This is not, right here, this one is not 2 triangles. That dotted line is just showing a height. That's not an actual side of it. It's not breaking it into 2 different triangles. Okay, up here it says Patrick drew a rectangular pentagon with side lengths of 16 centimeters. He divided the pentagon into 5 identical triangles. So all 5 have the exact same area because they're identical because it's a regular polygon, regular pentagon, and measured the height. He shows the height here at 11 centimeters. Now, the reason that he had to go out here and measure the height is because he actually had to go and figure out the right angle, and he had to connect it to this base. He called this the base. Okay, and then the height then would be from here to the very center. Okay, so how do we do this? Well, let's go down and look. He's going to find the area of the triangle. There's our formula that you guys should be very, very good at by now. He's going to find the area of that triangle. Okay, the one triangle. Let me do it in a different color so we can see. Maybe if I zoom out, that'll help. There we go. Hopefully you can still see it. I'm going to find the area of that triangle where all the dimensions are. So right here, and right here. And you can kind of think of it as its own triangle. You know what I mean? I mean, if you wanted to take it and redraw it with the new dimensions, but basically it's a triangle that looks like this. Okay, whoops, that's not a triangle. What's good enough? 16 centimeters, and then it's got a height of 11 centimeters. Okay, so we're going to find the area. Of course, it's 1/2 times base times height. You're going to get 88 centimeters. Well, that's the area of just one triangle. So what we're going to do is we're going to take that 88 centimeters squared, and we're going to multiply it by 5 because there are 5 equal triangles in the thing. So 88 times 5 would give us 440 centimeters squared. Therefore, we can see that we know the area of this pentagon is 440 centimeters squared. So it's very easy, actually. I think you guys are going to find this to be very easy. Let's do another one here. Let's look what this one's all about. It's the same thing. I'm not going to go through it all the way. Just going to kind of go quick. But you can see they took it and they divided it up into, they drew the center on there. Okay, there's the center. Okay, and then they created 6, because this is a hexagon, 6 equivalent triangles. And then you're just going to find the area of one of those triangles and then multiply it by 6. It's very simple, guys. Remember, your center is going to connect to every vertex of this hexagon. Okay? Every single vertex. Or I should say every single vertex. If you're talking if I'm talking about just a vertex, one vertex, if you ever want to say like multiple vertexes, the word is vertices. Okay, just so you know. So I don't want to hear anybody saying vertexes. It's not a word. It's vertices. So if you have 6 angles or 6 vertices, then that means that you will have 6 equal triangles. Okay? So if it's a hexagon, you know right away that it's going to have 6 sides, 6 angles, which means 6 vertices, which means it could be broken into 6 congruent triangles. Okay? And again, they knew the base and the height here. They figured out the area of that one triangle right there. They figured out the area of it, and then they're just going to take that and they're going to multiply it by 6. And that's how they got that area. So it's pretty easy, guys. I think you're going to find this to be very easy. Okay? Give the minimum number of identical triangles that I could divide this polygon into. Okay. Well, I see that there are 1, 2, 3, 4, and my pen would let me get up there, 5, and now I'm just ready to connect. Connect. And there's your 5. So the question is, how many equivalent triangles? 5 equivalent triangles. Okay, and I knew that because this has 5 sides, 5 vertices, therefore it has 5 congruent triangles. So how would I find the area of this? Well, I would have to know this distance right here, the height, and then I would have to know the base. And then I would do 1/2 times base times height, and then I'd multiply it by 5, because that would give me the area of the whole thing. This one, same deal. Here's your vertices, 1, 2, 4, 5, and 6. So I know it's got 6 sides, so therefore I know that it's going to have 6 equivalent triangles. Not perfect, but you get the picture. And again, I'm going to find the area of one of those, and then I'm going to multiply it by 6 because that's how many there are. The other way you could do it, remember, is multiplication is just repeated addition. So realistically, if you knew the area of that triangle right there was 10 meters squared, you could do 10. You could do it this way and do, hold up. You could get 10 by 10 by 10 by 10 by 10 by 10, and then you could just add them all up. But again, you guys all are good at knowing that showing repeated addition is easier with multiplication. Okay, so this would have 6 equal triangles. Okay, go to the next page. Okay. You can practice this one real quick. Do it together. Just write it with me. Okay, it's already broken down for you. So we're just going to go ahead and find the area of this triangle right here. Okay. Now, this one's it's the same thing, but I just want to make sure you guys are aware. Some of you might say, well, wait a minute, I don't know the length of this from here to here. Well, yeah, you do because of one word. Hopefully you know that word by now. It is that word right there. A regular polygon of any kind means all sides are the same. Let's write that. Regular means all sides equal length. Okay? All the sides are equal length. That's what a regular whatever, whether it's a regular hexagon, octagon, decagon, doesn't matter. Okay? So we know that all of these sides are 28, right? 28, 28, 28. We know that this is 28 also. 28 centimeters. Okay? And it gives us the height right here. Even though it's not there, you can see that's the same distance from right there to where the arrow is up top as it is right there to right there. Okay? It's the same distance. They just have it written over there. Okay? So you need to find the area of that. So we're going to write the formula because we always write the formula. Now we're going to plug in what we know. We know that it's 1/2 times 28 times 24.2, and that's going to give us an area. Let me get out my calculator because I don't know that off the top of my head. Okay, again, I'm going to use 0.5 as 1/2 because they're the same thing. 0.5 times 28 times 24.2, and there we go. 338. 0.8, I think that was. Yep, 0.8, and that's going to be centimeters squared because we are doing area. Okay, but remember, this is where a lot of you, I hope this doesn't happen, but I think we're going to see a lot of mistakes, is this right here. What I just found is the area of one triangle. This is just one triangle equals that. Okay, just one of them equals that. So we need to take that area, 338.8, and we need to multiply it by however many triangles this hexagon makes, which we know it makes 1, 2, 3, 4, 5, 6. So we need to multiply it by 6, and we would get, pull up my, okay, 338.6 times or 338.8 times 6 is going to give us 2032 and 8/10. And remember, centimeters squared. So when this is on the test, guys, I would expect to see a couple of different things. I would need to see this step right here, right there. I would need to see an answer here. I would need to see units here, and then I would have to see this. Now that doesn't mean you have to show me the math. Like, you don't have to come up here and go get 338.8 times 6. You don't have to show me that step. You can do that in your calculator, but I do need to see this. Then I would need to see this and this. So everything circled in black there I would have to see. Okay? And this works for any shape. I mean, trapezoids, you guys learned that formula. That formula is area equals 1/2 the height times the sum of the bases. Okay, you learned that great formula, and that's great. I bet you if you went home, and if you're at home right now, you can ask your parents. Ask your parents how many people know this area formula. There probably isn't very many of them because we don't use it very often. So realistically, this formula is great if you know it, but if you learn this decomposing skill, what we're doing up here, decomposing it into smaller figures, rectangles and triangles, you're going to be a lot better off. So you can see, here's my trapezoid, and I know it's trapezoid because the one classification to a trapezoid that makes it a trapezoid is the fact that it has one set of parallel sides. So I know this would be right here, my base 1. This here would be my base 2. Okay, and then my height would be right here because that's a right angle. Okay, so I know that. But look what I can do. If I didn't know this formula, I could still find the area of this. I'm going to take this and I'm going to come straight down like it did here. Okay, and you guys are going to see this real quick. What shape did I just create right there? I create a rectangle. I create a rectangle, so that would be base times height, and then I create a triangle, 1/2 base times height. Okay, that's exactly what we just created. So now I can find the area of this one, the area of this one, and then add them together, which is basically what we're doing. Okay, and then it even goes a step further. You could take it and take your rectangle then and divide it in half too. And then you got 3 triangles, 1 triangle, 2 triangles, and a 3rd triangle. But you don't have to do that. I think this one is perfectly fine right here. Okay, let's go to next page. Okay, divide the hexagon into 2 identical triangles and a rectangle. Okay, so let's, if my pen will let me do this, we will do it. Okay, so I'm going to take it and I'm going to divide it here, right? Create that triangle, and I know these are right angles. So now I know that I've created 2 triangles there, and I've created a rectangle in the middle. Now it wants us to divide the hexagon in another way. I don't want to do that. I'm not even going to worry about that question. I just want you guys to know that if I were then going to find the area of this hexagon, I'm going to then break it up and I'm going to find the height. Now it's really, really hard to see on mine. I think your copy might be a little bit better, but I can look here and see the base of that triangle is 1, 2, 3, 4. You guys see that? Can you see? I don't know if you can see the lines going across, but you can count them. There's 1 square, 2, 3, and 4 right there. That's how long my base is, which means this base is 4. My height is 1, 2. My height is 2. Okay. I know that this right here is base times height divided by 1/2, or times 1/2. Area equals 1/2 times base times height. That's going to be 1/2 times 2, or whoops, times 2 times 4. Okay, and that's going to give me 4. So I know that my triangle here, this triangle, has an area of 4 units squared. This one's going to be the same because it has the exact same dimensions, so that also has 4 units squared. Okay, now the area of this rectangle on the inside, I know it's 1, 2, 3 long, and it's 4 tall, I guess, if you want to think about it that way. I know that the area of this would be area equals base times height, which would be area equals 3 times 4, which is going to give me 12 units squared. Okay, now I'm ready to take this part, and this part, and add them up. And that's going to give me the area of the whole hexagon. So yeah, there's a formula out there that will find the area of this hexagon. It is. Absolutely, there's a formula. But why learn another formula when you can just simply decompose it into the triangle and the rectangle formula? So you got to know those 2 formulas, triangle and parallelogram. Okay, here you can see we took it. What's this one giving me? Okay, now this one gets a little bit more tricky, but still you guys can do it. Okay, trapezoid ABDE is made up of ABCE. Now that's confusing, but what it means is ABDE is a trapezoid. Okay? It's made up of square ABCE, so that would be that square and that triangle. That's all it's saying. It seems harder than it really is. The area of the square is 64 square meters. So I know the area of this square is 64 centimeters squared. Okay? Now, anybody that's thinking, well, how do I know what the length and the width is? Well, think. If it's a square, that means both sides are the same. So what's the only thing I can multiply by itself and get 64? Hopefully you're all saying 8 centimeters and 8 centimeters. Okay? Find the area of triangle ECD. Okay? So this triangle here, I know that this distance right here is 8. I know this is also 8 because look, this comes straight down at the right angle. This comes straight down at the right angle. It's still giving me the distance between the two bases of the trapezoid. Okay? So the triangle here would be area equals 1/2 base times height, and it's going to be 1/2 times 8 times 11, which is going to give me 44 centimeters squared. Okay? 44 centimeters squared plus 64 centimeters squared, that's going to give me 110 centimeters squared. Does everybody see how I did that? I found the area of the square, I found the area of the triangle, and I added them together. Now real quick, let's just quickly do the formula. You don't have to write this, just watch. We all know this formula, which is great if you do. But I'm just showing you that you probably won't remember that formula your whole life. I'm just going to tell you that right now. Okay, base 1 plus base 2. Okay, so 1/2, I'm doing the trapezoid now, I'm doing the whole trapezoid, times, what's my height? My height is 8, times the sum of the bases. And I know my base here, this right here, AE right there, hope this isn't getting too jumbled so you guys can understand. That's a base, and that is a base, right? So I know this base right here is 8, right? Because that's a square. So it's going to be 8 plus, and then what's my base down here? Well, it's 8 from there to there, it's 11 from there to there. Put them together. 8 plus 11 is 19. Okay. Now, just to save time, I'll tell you what the answer to this is. It's going to end up being, this would be 4 times, and then that's going to be 27. Okay, 4 times 27 is 100. Whoops, I did something wrong. Whoops. Okay, sorry about that. Obviously, this is 108 here, which is different than my answer. You guys are probably all screaming at the screen for the past 3 minutes here because I added this wrong. My bad. Sorry. When you add 64 and 44, you actually get 108. That was my mistake. Sorry. But anyway, you get the same answer. That's the whole point. So you can decompose it into smaller shapes, or you can use the formula. Now, if I ask for this, you got to do this. But it's pretty basic, pretty easy to understand.